Students, welcome in chemistry session. We are studying the parts of photochemistry, free radical reaction and pericyclic reactions. First we are discussing the photochemistry. What is the photo? The study of, as you can say, this is the light, study of light. Photo means light. In organic synthesis, various functional group concerned to synthesis. Organic photochemistry concerned to synthesis of various functional group based on organic compounds. Whenever the thermal condition is not suitable, whenever the thermal condition is not suitable, then another route is used, that is a photo, as you can say, a light, that is a sunlight. A chemical changes takes place by giving the energy. Chemical changes takes place by giving the energy. So both are it is one of the form of energy. Both are the form of energy, thermal energy and photochemical energy. Chemical changes takes place by giving the energy to reactant molecules and convert into the product. The energy is rise temperature giving energy to the reactant molecules. So this is called as thermal energy. What I can say? By a rising temperature giving energy is a thermal energy. The reaction is known as thermal reaction. A irradiation of the light, as you can say, irradiation of the light, irradiation of the light on reactant molecules, as we can say, giving the energy on irradiation of the light to the reactant molecule and convert into the product. Such types of the energy or the changes is called as what photochemical reactions. थर्मल रिएक्शन, थर्मल कंडीशन मतलब हीट के अकॉर्डिंग जो रिएक्शन होगा उसको थर्मल रिएक्शन कहते हैं. जो रिएक्शन सनलाइट के प्रेजेंस में होता है, फोटो इरेडिएशन सनलाइट इरेडिएशन के प्रेजेंस में होता है, उसको फोटोकेमिकल रिएक्शन कहते हैं. सो दिस रिएक्शन इज टेक्स प्लेस बाय यूजिंग द यूवी विजिबल, दिस वाट अ यूवी विजिबल, अल्ट्रावायलेट visible radiations. This is 100 nanometer to what 800 nanometer. So the range of the energy sources, as you can say, UV visible, it is used 100 to 800 nanometer. So the thermal reaction is easy to carry out compared to the photochemical reaction. Thermal reaction, it is easy to carry out than photochemical reaction, but the photochemical reaction are less common. Still there is an importance for the photochemical reaction in a naturally, as we can say, the carbon dioxide is treated with water molecule in presence of the chlorophyll. So as we have know this well known reaction, carbon dioxide with water molecule in presence of, this is the chlorophyll. So what happen in presence of the sunlight, then formation of here it is produced the carbohydrate. यहाँ पे carbohydrates formation होते हैं. How the carbohydrates is prepared by one of the photochemical reaction. This is nothing but as you can say, photosynthesis. Carbon dioxide is treated with water molecule in presence of the chlorophyll and the sunlight incident on the radiations, then formation of the carbohydrates. So this is what a photochemical reaction. So as you can say, this is the photosynthesis. इसको हम क्या कहते हैं? photosynthesis कहते हैं. Suppose if we are having some molecules, for examples, this is a 1,3 butadiene. This 1,3 butadienes, which is a irradiation of the heat, the radiations, then formation of what, the types of the compound is obtained. This is what, there is formation of cyclobutene. So this cyclobutene is obtained on irradiation of the light, but this is the highly strained molecule, highly strained. This is what, highly strained molecule. So another possibility for the formation of the product, it is if we are having the two reactor molecule is there. Suppose if we are having the two reactor molecules of there is a butadiene here. These types of the reactor molecule is react with the butadiene's molecule, two reactor molecules on the sunlight irradiation, formation of what? Here there is a possibility for the formation of the product is cyclobutene derivatives. This is formation of types of the compound is here. How many carbon atom? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7 and 8. So how the part of the mechanism is takes place? We are having the types of the compounds. This is 4 plus 2 cycloaddition reaction is takes place. This cycloaddition reaction is takes place, and then formation of what? There is these types of the bond is break here. Again this formation of what? These types of the compound. So this is the part of the mechanism of this reaction. Cyclobutadiene. Butadiene is converted into what? Cyclohexene, and this is what a derivative of the cyclohexene. So here if we are having the 1 mole of such types of the compound reactant molecule butadiene, this is on the sunlight irradiation, here the possibility of the product is formed this word. So this is the highly strained molecule. But another possibility for the formation of the product, this is the unstrained molecules. So it is depend upon the energy sources. तो कौन सा एनर्जी सोर्स यहाँ पे यूज करना है? सो देर इज डिपेंड अपॉन द टाइप्स ऑफ द रिएक्टर मॉलिक्यूल. फॉर एग्जांपल इफ वी आर ऑन द बेंजीन मॉलिक्यूल्स, so this benzene molecules on irradiation of the light on the benzene molecule, there is formation of what? Here product is obtained. This is called as this one strain molecule is formed. Another possibility, there is formation of this strain molecule. As you can say, this is the non-aromatic compounds. It is a non-aromatic compound. So these types of the molecule is called as fulvene. The name of the compound is called as what? Fulvene. See, this is the formation of the fulvene molecules, irradiation of the sunlight on benzene nucleus. So this is depending if we want to synthesis of the strain molecules, it is most convenient for the photochemical reactions methods. As we are having the another types of the reactor molecules, for example, this is a maleic anhydride. So the next another molecules we will take, this is a maleic anhydride and fumaric anhydride, as we have in the part of the basic. So this is what a maleic anhydrides. So maleic anhydride is condensed, as we can say, this is the dimerization. If 2 moles of the maleic anhydride, dimerization is takes place, and then formation of what? The dimer product. Here formation of the dimerized product. As you can say, this formation of the adduct. The name of the product is what called as adduct. Here the formation of dimerized product. This is called as adduct. This is called as adduct. So dimerization is takes place. So as a part of the basic of how the reaction is carried out, the starting reactor molecules is what? It is strain molecule is formed. Whenever you use the strain molecules, for example, if we are having the starting reactor molecule is what? 7-member types of the reactor molecules. This is the 7-member reactants which are having the unsaturated compound C double bond O. Whenever we use, this is the radiations incident of the sunlight, UV visible radiation 220 nanometer, and यहाँ पे हम लेते हैं 280 nanometers. So what happen? There is formation of the possibility of the product here. Here there is formation of the strain types of the compounds like this. This is the formation of the strain molecule. Here formation of strain molecule. But whenever we use, this is the high nanometer range, sunlight irradiations, high nanometer range, there is a possibility of the product is formation of, this is called a cyclic compound. This formation of a cyclic compound. This bond is break by homolytically cleavage, formation of the radical species. This is how the radical is obtained, and this pi bond is also break. So there is formation of the radicals. As we can say, the basic part of this is the to cleavage of the bond. To cleavage of the bond by what? Homolytically cleavage, and then formation of the radicals. Breaking of the bond or fission of the bond. Breaking of the bond or the cleavage of the bond, there is two methods, as we have the basic part, homolytically and heterolytically. The bond is break by homolysis and heterolysis. Whenever the bond is break by heterolysis, there formation of the what? Positive charge and negative charge species. By homolysis, there is formation of what? Electrons, and that is called as what? A radical species. So the bond is break by homolytically and heterolytically. So whenever, what is the roles of the photochemistry in these types of the reactions? Whenever we use the 2 to 0 nanometer range UV visible and 2 8 0 nanometer range. Here less energy required to formation of the strain molecules, but whenever we use the more energy UV visible, then formation of what? A cyclic saturated compound. This was acyclic unsaturated hydrocarbons. The bond is break by homolytically. The radicals is formed, and this radical and this radical is combined. This radical and this radical is combined. Then is formation of the bond between the carbon. There is formation of the 3 pi bond, and here the formation of what? A strain molecule. Here formation of what? Strain molecule. So this is the role when we use the reaction condition, as we can say energy sources. Here the energy sources is more than this one. We are applying the part of energy concept. Before that, how the electronic excitation takes place as a part of the photochemistry. Excitation of electronic excitation. Electronic excitation or excitations, how? If we are on the starting reactant molecule is what? CH3. If we are having the CH3 molecules which is on the incidence of the radiation, what happen? These types of the molecule is consist of the sigma bond only. इस molecule में सिर्फ sigma bond present है. The sigma bond present between the carbon and carbon hydrogen. So as a part of the sigma, so this bonding concept and anti-bonding concept. So bonding molecular orbital and anti-bonding molecular orbitals. So part of the molecular orbitals is a concept from the valence bond theory, VSEPR theory and valence bond theory. So the molecular orbital theory, again what? Crystal field theory and molecular orbital theory. Here the bonding molecular orbitals is goes to anti-bonding molecular orbitals. Here if we are having the sigma bond, so this sigma bond is converted into what? Again sigma. So this concept we are applying, the star is there. So the electronic excitation takes place sigma to sigma star. Electronic excitation takes place sigma to sigma star. So as we can say, these types of the electronic, the ethane molecules obeys sigma to sigma star. If we are having the next molecules, we are taking the CH2 ethene molecules. So this ethene molecule which contain the sigma bond and pi bond. So how the electronic excitation takes place? Here the electronic excitation takes place how? Bonding molecular orbital to anti-bonding molecular orbital. So there is consist of the what? Sigma bond. Here where representation this sigma and pi, again this pi and sigma. So their electronic excitation takes place. This is the anti-bonding. This concept which are having the anti-bonding molecular orbital, and this is what? A bonding molecular orbital. So how the electronic excitation takes place in given molecules ethene? The sigma to sigma star, as you can written sigma to sigma star. Here the electronic excitation takes place sigma to sigma star, again what? Sigma to pi star. So here the electronic excitation takes place again pi to sigma star. I am writing here pi to sigma star. इस मॉलिक्यूल में सिग्मा टू सिग्मा स्टार इलेक्ट्रॉनिक एक्साइटेशन होगा, उसके बाद सिग्मा टू पाई स्टार होगा, देन पाई टू पाई स्टार एंड व्हाट